Hello everyone and welcome. Thank you for joining us today. My name is Jason Rutledge and I'm a CAD/CAM software specialist here at AXYZ Automation Group. I work directly with the PANELBuilder software on installations, training, and troubleshooting, so I'm excited to guide you through some of our most frequently requested training topics. Here's what we'll be covering in today's webinar: how to add new material to your library using fiber cement as our example, creating and nesting a complete project from start to finish, and how to update your settings in compiler for your feeds and speeds to make sure you are running at the optimal speed for your machine. At the end, we will wrap everything up and have a few options for links regarding what you might be interested in. Let's start with one of the most common requests that we get: adding a new material to your library. For today's example, we'll use fiber cement. Step 1 is opening the material library in PANELBuilder. Just head to the Parts tab, click on Configure in the top menu, and then choose Standard Sheet Editor. If you do not see Configure in the top menu, make sure you are not in 2D CAD, as that does not appear in that option. Here you'll see a list of materials already in the software, including different thicknesses and sizes. Let's open ACM, where you can see that has been captured with the 3mm, 4mm, and 6mm, and then the different sizes of sheets listed in those thicknesses for the material. To create a new material profile, instead of having to enter all of the critical information like the material thickness, density, and sizes manually, you can duplicate an existing material in the software. Select a similar material, then choose Copy Material at the top. This opens a new window where you can rename the material in the material field. Please note it's best to choose a material that shares similar cutting properties with the one you're adding. We will use the fiber cement saw for replicating the fiber cement router. We've updated our name here and we selected OK. And then you can see here it has the 8mm, 10mm, and 12mm captured from the fiber cement saw. You can also see it has captured the sizes as well from that list. Now, let's say you needed to add a new thickness for this material. To do so, you can do similarly to what you did with the copy material, but you have to select a thickness within the material you're looking to add it to. From here, you click on the copy material that now is labeled as copy thickness. We're going to add a 16mm thickness to the fiber cement. You can see it's now appeared in the list here, and if we click on the drop down, it opens up the different sizes of the sheets, which captures similarly to the 12mm that we copied. With our fiber cement in various thicknesses added, let's move on to applying it in a real-world project. Next, we'll create a sample project using our new material. We're going to go into File, make sure we're in 2D CAD, File, and New Project. We're going to hit No there because there's nothing we need to save. And we're going to call this project Webinar Training for today, and hit OK. And we have now created our project in PANELBuilder. From here, we're going to start by drafting a few panels for it. So we're going to make a regular panel first. To do so, we're going to make sure we're in 2D CAD. In our drafting menu, we're going to go to the Shapes tool. As you can see here, we now have a basic rectangle we're going to switch to this one right here that gives us the option of corner details. As we can see, we already have it selected with the notches here, as well as a preset size. So we're just going to add that to our drawing right now. And as you can see, it is listed here with the white full line. As I'm sure most of you are aware, with PANELBuilder being a parametric software, the pen, tool, and the line type help to identify what each line is meant to be instead of doing it through layers. This is also done through our global settings, where you can see if, per se, we were to add a pen to line with the chain line type, that would use the 110-degree center line cut. So for any bend lines. So we're going to do that next. We're going to select the pen tool here. We're going to do selected lines. We're going to switch to pen 2 and chain line. We're just going to add that right here to our drawing. Okay, now that we have our bend lines added, we need to dimension out the shape. Because as mentioned, with it being parametric, these need to be identified for redimensioning or anything of the sorts. So we can see here, we have these dimensions locked in and everything seems to be green. We're going to go through, dimension out our bends here. Now, let's go through and test our dimensions here, make sure we have everything sized correctly. So if we were to change this to 15, we can see our bend line up here has been altered. This is because we did not dimension that. So if we hit the undo tool here, go back up here, and dimension that in. If we were now to go back to our settings, edit this back to 15, everything should now stay the same, which we see in our shape here. What we will also do is increase this to 60, just to make sure everything works. As we can see, everything has stayed correct within the shape and how we've designed it. The next step now is to label our dimensions. So we're going to call this one X and this one Y. We're also going to label each one of our returns with an R here. So now that we have this, we're going to go to PANELBuilder here, manage templates, and we're going to save this as a new panel. We're going to add this to the webinar group for today, and we're going to call it a regular panel. We're going to add the material to it, and we're going to add our fiber cement router with the 15mm thickness. We're going to hit OK there, and now we are going to lock our dimensions in for this shape. So we'll make this the X, this the Y, and then R for our returns. Now we have 4 bend lines on this, so we need to get these captured. We're going to capture those on the X and the Y, and then we're going to put 0 for the returns. The reason for this is you only need to capture each return once, not repeatedly. So even though all returns touch one line, we have it captured referenced between the X and the Y. So we're going to label our X length to make it more easier to follow, and our Y height. We're going to make the R for returns, and now everything has been identified here, so we can save that in our library. Now let's say we needed to add a corner panel to this. What we can do is already take the panel we've created here and edit it to create a new one. So what we're going to do first is get rid of the dimension we have up here, and then we're going to go here to our notches and corner details. We have our one tool here that has already opened our V notch. This lets us add a corner detail, and we have a few different method of options here, but we're going to use the angle, and we're going to go by the center of it. the arc and depth allows us to change the depth and the angle of it. One thing to keep in mind with PANELBuilder, with it being a parametric software, you want to change the angle from 90 to something else. The reason for this is the software has the ability to get confused with a corner detail and will lock it in sometimes. So that way, if you are ever needing to edit in the future, you don't have the ability to do so. So we're going to add our corner notch here, and we're going to add one below. The next step for this is we now need to add a bend line to it. So we'll go back to our pen tool, and we can see it has our previous settings still saved. So we're going to click there, and now we have that captured. Next, we'll be adding our dimensions. So we're going to need to dimension the top up here separately. So we'll just do that. And then we're also going to need to dimension the angle. We're going to go here, click this side and then that side, and now we have our angle dimensioned at 89. So we're just going to edit this just to make sure everything works and fits within the dimensions provided. So what would happen if we were to change this to 20? Okay, everything looks good. Now let's say we made this one 5. And you can see our corners are now mixed up. This is because we did not dimension the top corner. There's a reason why we didn't do that though, as if we were to dimension both of those, it would lock it in. So what we can do instead is use a reflecting tool. So we're going to go back to our pen here. We're going to switch this to pen 0 and use our dotted line, and we're going to make it symmetric. We're going to place this at the halfway mark. This now allows it to replicate what is on one side to the other side. So you're going to see when we check our dimensions here, these are now both red. The reason is because it's dimensioned up here and it's dimensioned down there. So it's conflicting with the symmetric line we've just added. So if we were to remove the dimension up here and then we check again, we can see everything is great now. And let's say we were to test this one again and make this 5, we can see all of our corners have stayed perfectly fine. Now let's increase the size of this to 17 just to make sure that everything is working there. And we can see this has all been saved. So now we're going to need to relabel the dimensions we've added. So we're going to do x1, x2, and then A for angle down here. We're going to hit close, and then we're going to add this to our templates. We're going to keep this in our webinar one as well, and we're going to select. We've got webinar. We're going to name this one corner panel. We're going to add the material to it, which has been pre-saved from the last time we've done this. Now we're going to go through and add our angles to this. We've got our x1, our x2, y, our angle, and our returns. So now we have 5 bend lines. So we're going to mark 2 under x1, we're going to mark 1 under x2, and 2 under y. So that way all 5 have now been captured here. And we're just going to put a 0 here and a 0 here, as there's no need to capture them anymore. So we have length 1, length 2, our height, our angle, and then returns. And now we're going to hit OK to save this one into our template. So now we have a regular panel and a corner panel. One of the other common panels that we get asked about a lot is a column corner panel. So I will show you how to make one of those as well. It's very similar to the process with a corner panel, but we're going to add another corner to it. So we're going to take our dimension away right there. We're going to go back to our corner notches tool, and then we see we have our settings from before. We're going to change the angle though from 89 to 88. The reason for this is so that way we can separate it from the other angle we have So that way, if you are ever needing to make them at a different degree, you have the ability to do so. And then we're just going to change the distance here as well, just to lower any risk of the software getting confused between them. So we have our corner created there and our corner created there. We'll go here, we'll go back to pen 2, and the chain line, we're adding our bend line to this. Next, we'll just need to add our dimensions. So we will dimension out from here to here. Oop. Because we have our angle tool, so we need to switch back to our line tool. And there we go. Now these are dimensioned, and then we will need to dimension the angle as well. We'll put that one in there. And then what we will do is just test just to make sure everything is correct and that this does not cause any issues anywhere. Okay, our angles and everything is looking good there. And then everything is looking good there. So we're good to label everything. So we'll go here. We have our X1 still. So we will go with X2, X3, and angle 2. Close. Now everything has been identified here. So again, we'll go back to manage templates and save this as a new template. So we're going to call this one a corner column. And again, we're going to add the material to it, which has already been pre-captured from last time. We will now add our X1, our X2, X3. Looks like a mistake was caught there, but that's okay. What we can actually do is go back to our tool right here where we have this open and make sure our labels are correct. So we'll put that one to A2 and then make sure that's X3 now. And we can close. And then go back to our tool here, so we'll hit set again. And then see that's now been switched back to X3. We have our Y, we'll add our angle 2, and our returns. So again, we will add our bend lines to these. So we'll do 2 for X1, 2 for X2, 1 for X3, and 2 for Y. And then the rest we will put at 0. We'll now label these. Length 1, length 2, length 3, height, angle 1, angle 2, their returns. Labeling and saving templates is a huge saver, especially for recurring jobs. You will see the benefits once we start adding the parts to the project. And now we've saved our templates, we will add our parts to the project. So first we're going to go to Nest. And it's going to bring us to this screen here, where you can see that we now have our nested sheets to appear here, and our parts and sheet material to appear down here. So what we're going to do now is we're going to click on PANELBuilder and build panels. We're going to click no here because we've already saved that as a template. So we can see on our webinar here, we have our regular panel. We have the length and height that was identified before, but with us having labeled everything, we can change this. So we're going to make it a 40 by 20 panel. We're going to put 5 of them, and we're going to call this FC-001. And then so you can see with our settings here on the right, we have it going to our project that we've created. The materials already pre-specified because of us having done so when we created the template. The allowed orientation stays like that unless you need to change it. The nest option, we have it going to the current project, so everything will be saved properly and accordingly. We've updated our quantity and identified the panel reference. So we're going to click build panel here now. And the following part has been created. So we're back here. We're going to add a corner panel now. So we're going to go into here and we're going to make it 20 by 20 by 30. And then we're going to make our angle the 90 degree. We're going to add 5 of these as well. And we're going to call it FC-002. And as you can see as well, because we did specify the material and the thickness, that has all been saved here with the project. And again, it's going to our current nest. So we're going to click build. And now we've built that panel out. So we're just going to add the last panel we created, the corner column. We've got that one up here. So we're going to go make it 20 by 20 by 20. We'll make the height 30 as well. And then we'll update both corners to be 90. And again, is saved to the project we've already created and opened for this, the material and the thickness that we've specified, and it's all being saved to the current project. So we're going to update our quantity, and then we're going to call this one FC-003, and we're going to add this to our project as well. So now that we've got our 3 panels, we're going to hit close here. We're going to go back to nest, and we can see we now have the 3 parts listed in our template here. Now we need to add a sheet to this. With us having added the fiber cement, the router, we're going to go through 16 millimeter, and for the project today, we're just going to put it to unlimited. Typically, you would want to specify in here the number of panels that you actually have to work with. That way there's no risk of it overcutting or anything like that. But just to make things simplified, we're going to do unlimited. Now we can hit close here. We have our sheet specified and our parts specified. So now we're going to go through and nest the project. So we're going to click the Run Nester button here, but we're going to click on the drop down and go to multi-part nesting settings. This allows us to update and adjust how the nest is going to be made. So we can see here the project it's pulling to, and then over here we have it's going to the STL default. We're going to update that to the fiber cement because of using the fiber cement material, and we can see that our part placement is set up to the maximum utilization. On top of that, we're going to update our nest here to 999. The reason here is so that way it will nest the complete project without just doing a partial. You can adjust this whenever you are in the nest settings. So we can see here it's pulling from the sheet we've added, so everything is good there. We have our clearances. We have our clearance specified up here, as well as a few other dimensions that we can control. We're going to leave the rest of that the same, and typically it is recommended to do so, with the only thing that is advised to change here is the part XY gap, depending on the clearance you need. This is if you are capturing any remnant scraps from the sheets you're using. We're going to leave it off for now, just to help make this a little bit more simplified for everyone. We want to make sure automatic tooling is selected. Our order we're going to do by AOTEX1. This does it as what the system perceives to be the highest utilization. There should also be the option for part by part or tool by tool. If you see any other ones in there, they would have been custom ones that you guys have added or that you've got us train you on adding. So we're going to add compile blocks as well, so that way it runs all the feeds and speeds for this, and we're going to select Run Nester. We're going to hit yes to all. Alright, and now the software is going through and updating all of the settings for it. So we've had our 3 sheets created with our 3 different nests. We're going to hit OK and take a look here. So we can see over here the 3 nests have been created, and this sheet specifically here has 2 of the 3 parts we've made. It's got 4 of the one of the other. So you can see what tools have been used here. So we have the 1/4" flute, the 110 V-bit, and our marking tool for any labels that would need to be added to the project. Next, we will go to compiler to update the feeds and speeds for fiber cement. Your compiler is the link between PANELBuilder and the actual machine cutting for your nest. It updates how the tools will cut your parts. If this is not updated with the latest feeds and speeds for your tooling and material, you risk inefficient cuts or damaging your tools, and the potential of even breaking them. We're going to start by going into compiler here and updating the settings. What you can see here is we have condition 1 and condition 3. This is specified with the TN number, which is the tool number. If you are ever confused by the identification in PANELBuilder, that is okay. If you look to the right of your screen here, you do have the description as well to help identify that. So we're going to update our 1/4" bit here. We're going to change the spindle speed from 24,000 to 15,275. We find this to be a good starting point for fiber cement. Next, we're going to update the piercing to 80 inches per minute, and then we're going to update the feed rate to 50 inches per minute. And then from here, we're going to add a ramp, make this 5 degrees, and then we're going to change the ramp feed rate to 50 as well. We're going to hit OK here. This will give us a little bit of an error, but that's okay. The error that's appearing is telling us that this is going to affect any drill holes that we have as well. With us not having any drill holes in any of the parts we've created, there is no risk of that. If you do have drill holes in your project and you are using the router bit, you would need to identify this with a different station tool, and then that way in compiler you can update the settings for the one without reverting the other ones. So we're going to hit OK here, and then we're going to go into verify just to make sure that all of our cuts are happening. We're going to change the speed here so that way we can just make sure everything is cutting properly at a pace that we can actually see. So we're going to hit play. And then so you can see it is updating the information based off of what tool is in use, the speed that it's running at, the feed, the depth, and if coolant is turned on. So it is starting with the internal cuts first. This is so that way if it does the profiles first, it does have the risk of misaligning these cuts due to the parts moving. So the internal cuts are always done first before the profile cut at the end. Okay, so verify has run its course and we can see all parts are cut with all lines provided. This allows us to know that the nest is being cut properly on the machine. Verifier creates a replication of what you would see on the machine, such as a simulation of it physically cutting. We always advise running your projects through a verifier just to make sure that everything is cutting correctly with it. And if you noticed, our changes were reflected immediately on verifier with the tooling that we have updated. The NC file would have been created from this within the nest, and you can see that within your project folder. From there, you can now send this to the machine for someone to go through and provide the actual cutting there. Today we covered a full workflow, adding new material, creating parts and nesting a project, as well as how to update the compiler for the project. These steps combined will ensure you are setting and cutting new material accurately from the start of your production. If you ever order any router bits through us, you can always reach out to our customer service and we'll assist you with providing the feeds and speeds for the material you are cutting. Thank you all for attending. We'll be sending out a recording of this session along with a quick reference guide for the steps we covered. If you need further training or want to explore advanced features, reach out to our support team and have a great day. Happy cutting, everyone.